Hello everyone, this is a brief tutorial about building a reinforced concrete frame with clay brick infill against blast loading. So as a start, we start by creating a part which is masonry. We make sure that's 3D deformable solid extrusion. Approximate size is about 20. Now we choose the rectangle from here, and the starting point is going to be 0, 0. The end point is going to be 9.2, 3.6. Now ABAQUS is asking about the depth of the wall. So the depth of the wall in our case is going to be 0.075 for clay brick. So here's our clay brick wall, as shown here. Now the second part is going to be the concrete frame. We also make sure it's 3D deformable solid extrusion. Now this concrete frame has to be around the clay brick, so we're going to choose create lines connected, as shown here. And the starting point, let's say 0, 0, then 0, 4, 10, 4, 10, 0, 9.6, 0, 9.6, 3.6, and 0.4 with 3.6, and the last one is 0.40. Now we connect that together and done. So the depth of our concrete frame is going to be 0.4. So the beams and columns here are 0.4 by 0.4. Now we have our concrete frame here, as shown here. So what we need now is the reinforcement for the concrete frame. We call it reinforcement, or actually top steel. This time for the reinforcement we choose wire instead of solid, planar wire, approximate size 20 again. Now we choose connected lines for the top steel. So the first one, let's say the starting point is 0, 0, and the end point is going to be 9.20. So now press on X. So that's our first line here. That's our first line here. Now we make another line with starting point as 0, 0.3. So the spacing here between the vertical, between the top steel, is going to be only 0.3 meters. So the end point here is going to be 9.2 with 0.3. Now done. Now we have our top steel here. So what we need now is the side steel, which is going to be used for the columns. So side steel. Here we also make sure it's wire, planar, approximate size 20. So for the side steel, the starting point, also connected line of course. So the starting point is going to be 0, 3.9, and the end point is going to be 0.3, 3.9. So the starting point is going to be 0, 0 here, with and the end point for the first side steel is 0, 3.9. So that's our first steel. Now we'll make another line. So it's going to be from 0.30 till, so the end line is going to be 0.3, 3.9. So here we have our side steel ready as well, as shown here. So we have the concrete frame now, masonry, side steel, top steel. So what we need now is the link the steel link to make the cages for the reinforcement. Steel link. So we make sure it's wire again, planar 20, continue. So we choose the rectangle. So 0, 0, and the endpoint is going to be 0.3, 0.3. Now we have our link ready as well. So now proceeding with our model, we go to property. Here we have three materials. So we go to create material. So the first material is going to be masonry. So first we go to general here, density, mass density. It depends on the type of masonry you have. For our cases, we're going to use the 2000 kilogram per meter cubed. Now we go to mechanical, elasticity, elastic. Young's modulus here is going to be 15.8 e to the power of 9, and the Poisson's ratio is 0.19. Okay, so now we have our first material. We create a second material, which is going to be concrete. For the concrete frame, we go to general as well, density. The mass density for concrete is 2400, and we go to mechanical elasticity again, so it's elastic as well, with a Young's modulus of 17 e to the 9, and Poisson's ratio is 0.15. Now a third material has to be done, which is also steel. So we go to general as well, density, mass density. The mass density of steel is much higher than that of concrete and masonry, so the mass density is 8050. We go to mechanical elasticity, elastic. Young's modulus here is 200 e to 9, and the Poisson's ratio is 0.3. Now we proceed. Okay. Now we have to create sections. We go to create section. So the first section, we're going to call it masonry wall. Masonry wall. Here, for the masonry wall, we use solid homogeneous. Continue. Now the material for masonry wall is definitely masonry. So we make sure that the plane stress strain thickness is 1. So okay. Now we create another section, but this time for the steel reinforcement. For the steel reinforcement, choose beam and truss. Okay. Now it's asking about the material of the truss, which is definitely steel, and the cross-sectional area for the 30 millimeter link. So what we're going to choose here, the reinforcement we're going to choose is 30 millimeter diameter steel bars. So the cross-sectional area for this is going to be 706.86 millimeters squared. So which is okay. Now you have to make another section, but this time for the steel link. So it's again beam truss. Okay. The material is steel as well. The cross-sectional area here is different, of course, because for the steel link we use 10 millimeter diameter links. So the section area, the cross-sectional area is 78.54 millimeters squared, and press OK. Now a third section has to be done, which is for the concrete frame. Solid homogeneous here. Continue. Material is concrete. So after creating all the sections, we assign the sections. So we go to assign section. So we select the regions to be assigned the sections. So let's say this one. Done. So for set one, it's steel link or steel reinforcement. Steel link. Okay. Now we change from here to top steel. We assign section here as well. So we highlight reinforcement. Okay. set 1 is going to be steel reinforcement here. Okay. Now we go to side steel. We assign section as well. So it's going to be, the section is going to be steel reinforcement. Okay. Now masonry, for masonry, we assign the section for masonry. So we highlight masonry now. Done. We choose masonry wall. Okay. Materials masonry, solid, homogeneous. So make sure everything's alright. And for the concrete frame, this is the last section to be assigned. We assign section for the concrete frame, highlight it, done, and then choose concrete frame. So now we have all the sections assigned with their properties, and we're going to move to the next section. So after making all the parts and the sections and assigning all the materials to their sections as shown here, so just make sure that all the sections have their own materials. Now we proceed to assembly. We go to create instance. So we add the side steel with the steel link. So press shift on both of them. We'll make sure it's independent so that the mesh will be on instance, and press on OK. Now as we can see here, we have to rotate the link in order to make the reinforcement cage. So we go to rotate instance, we highlight the link. Now it's asking for the axis of rotation. So here the axis of rotation is going to be this one here, and 90 degrees. Okay. So now just to make sure, so yeah, everything is ready to add the steel bars and the other links. So okay, now we go to linear pattern. We choose the side steel bars. Done. Now so as we can see, we can make a lot of patterns here, but the one that we need is this one here. So we choose the direction. The direction will be, so we try one of the sides. So this one, yeah, it worked. Now it is ready to add the steel links. So as you can see, now we go to linear pattern again. We highlight the steel link. Done. Dismiss. So we put this at 0 and 0.5. So 0.5 is the distance between the steel links. So we're going to make, so let's just check. So we're going to make 7 steel links. Now press OK, and our first column is ready. So this is our first column. It's ready. Now after making the reinforcement for the first column, we have to make another one for the second column. So we go to linear pattern, we highlight the reinforcement for the first column, and make another reinforcement, as we said. So here we have 2 reinforcements for both columns ready. So we add the side steel, top steel with the steel link independent auto offset. Okay. Now we have to move the link in order to make the steel cage of the beam. So as you can see here, we have to rotate this link in order to make the cage. So we highlight so here the axis of rotation is going to be here, 90 degrees. So just to make sure, yes, it's ready. Okay. So we go to linear pattern. We choose the top steel bars. Now we don't need this one, so what we need is this one here. So here we have to change the direction in order to make the reinforcement. So we choose this direction in order to make the cage. So okay. Now we have to put the links into the cage. So we go to linear pattern again, choose the link, done, as you can see here. So we need this one. So we put more here and replace the direction. So we make this one. And we make the offset as 0.5, as the distance between the link is 0.5 in our case. It depends on the model you're having. So now the beam is ready to be installed into the concrete frame. So after making all the reinforcement for the columns and the beams, we have to put them into the concrete frame. So we go to create instance, we insert the concrete frame as independent as well, and press on OK. Now we start by moving the instances that we created into the concrete frame. So the select a start point for the translation vector. So we choose a point on the edge here, and then we go to almost the same point on the, as you can see here, the concrete frame, or actually the beam, is now reinforced. So what we do now is we go to the first column. So we go to move instance again, translate instance. We highlight the first reinforcement for the column. Done. So we choose this one here. And then choose this one here. So as you can see, the first column is also ready. Okay. Now we have to put the reinforcement for the third column. So translate instance, we highlight again. Done. We go to, so the first point is going to be also on the edge. And on the edge here. Now it's okay. Now, if we want to edit any of the arrangement that we have created, so after the translation, so we go to View, Assembly Display Options, go to Instance. Now, we can hide anything we want from here. So if we hide the concrete frame, apply. Okay. Now, I want to move this one slightly a bit to join the beam reinforcement. So what we do is, move, translate instance, we highlight the column reinforcement, translate it. So we move this into this. Now the same with the other direction. That direction is also ready. So if we go to View, Assembly Display Options, Instance, and then highlight the concrete frame, press Apply. Okay. Now, as you can see, our concrete frame is all ready with the reinforcement. So what we need to do is now we need to add the masonry wall. So we just create instance masonry and apply. Now we have to translate this wall here. So what we do is we translate. Okay. So translate, we choose the wall. So we go to one of the edges of the wall. We go to the second edge and press here. Look, as you can see. Okay. So now our wall is ready. Our reinforced concrete frame with unreinforced masonry. Everything is ready now. Run. So we have to introduce the blast load. So first we go to step, create a step, we'll call it explosion. So here we have to change the type into dynamic explicit, continue, explosion, explosion. The time period here is going to be taken 0.01 for the explosion. Non-linear geometry, we set it off. Okay. Now after creating the step, we need to make the interaction. So as we said here, it's masonry wall and a reinforced concrete frame. So what we need to do here is make an interaction, create an interaction between the masonry and the concrete frame. This is done by create interaction. So it's surface to surface contact, explicit, continue. So it says select the first surface. So in order to select the inner surface of masonry, we have to go to view, assembly display option, instance. So we turn everything off except the masonry. Apply. Okay. Now we choose the three sides that are touching the concrete frame. So this is the first one. We press on shift. This is the second one. And that's the third one. So press on done. Select, choose the second surface type. So we choose surface again, but now this time it's the opposite. So we go to view display, view display options. We put everything off except the concrete frame. Now press OK, apply. So the three surfaces here are, this is the first surface, this is the second surface, and this is the third surface. Now done. So here we have to change it to penalty contact method. Now we go to here, we make it contact. Okay, mechanical, tangential behavior. We change the friction formulation from frictionless to penalty. The friction coefficient between the masonry and the reinforced concrete is 0.7. So it's added. Okay. Now, as we can see, the interaction is created. So in order to make everything shows, we set all on, apply. Okay. Now, the next thing we have to do is create a constraint. So create a constraint. We have to create a constraint here because the steel reinforcement should be embedded inside the concrete frame. So what we choose is embedded region, continue. Now, what we need to do is we have to select all the embedded regions. So we go to assembly display options, we set everything on except the concrete frame, masonry, and that's it. So apply. Okay. So we highlight the embedded region. Done. So this now we have to highlight the host region. So we also go to view, assembly display options. So we set everything off except the concrete frame. Apply. we keep these all default and go to continue. So now we have the steel as embedded region as well. The next thing we're going to do is introduce the load. So introduce first the amplitude. So the amplitude, in our case, a van or a pickup full of TNT, which is about 1,814 kilograms, explodes opposite to a wall, and the standoff distance between them is about 10 meters. So using Brody's equation, the pressure was found to be 1,315,380 Pascal. So we go to create amplitude, X, or let's call it blast. Now we go to tabular, continue. As you remember, we made the step time as 0.01. So at 0 seconds, the amplitude should be the maximum, which is 1315,380. Now, and at 0.01, the amplitude should be 0. So now we created an amplitude. After the amplitude, we go to load, create load. The load is van 10 meters away from the wall. So we go to mechanical, so it's pressure, which is the type of the step as pressure. We go to continue. Now we have to choose the surface that the pressure is going to be applied on. So what we do is we go to view to show all the masonry wall, set all on, apply, okay. Now the load is going to be applied on the masonry wall as well as the concrete frame. Now it's done. The magnitude is put as 1 and the amplitude is blast. As you remember, we just made the amplitude. Now press OK. As you can see here, all the load shows now. So after creating the load, we go to boundary conditions, BCs, create boundary conditions. So boundary conditions, we have to make the wall fixed from the base. So we call it fixity, mechanical, symmetry, and encastre. Continue. So select regions for the boundary conditions. So this is the first region. That's the second region. And that's the third region. Press on done. Make sure it's encastre to make sure that it's fixed from the base. Now we can see the fixed points here. And as we zoom out, now the model is all ready for the meshing part. So we go to mesh. Now in the meshing part, we have to mesh every material by its own. So first we go to assign element type. So let's start with the masonry wall. Done. We choose standard, linear, and we tick this off. So for the concrete and the masonry, we tick the reduce integration off, and everything is left as default. Then OK. Now, same thing for the concrete. Then we tick this off. OK. After that, we go to seed part instance. We press on the masonry wall. Done. So here we choose our mesh size. So let's say we choose 0.1. Apply. OK. Now we do the same thing to the concrete frame, which is 0.1, and apply. Okay. Now the last thing we need to do is we have to put mesh for the steel reinforcement. This is done by, so we have to set all off except the steel bars. Okay, so now all the steel bars, we go to assign element type, highlight all the steel bars. For the steel bars, we go to we scroll down to truss and choose OK. After that, done. So we highlight, we go to the approximate level size is taken to be 0.05 for the steel, unlike the concrete frame and the masonry. Now we go to instance to give it the meshing, and same thing for the rest of the structure. So continuing with the meshing of the wall and the reinforced concrete frame with the steel bars. So unfortunately we had to make the meshing bigger because this software is a student version, so it allows only 1000 node. So that's why I changed the mesh into 0.5 instead of 0.1. So we press mesh part instance now, and then choose the masonry wall. Done. As you can see, the mesh is all around the masonry wall. Now we create we mesh part instance again for the concrete frame. Press OK. Now as you can see, everything is ready for the job, for the results. Now we go to job, create job, so we call it EXP 10 meter run. Continue. Now OK. Now scroll down to jobs. Our job will show here. So we right click on the job and then submit. We just wait a few seconds until the results are given. It's running. Of course, the results won't be as accurate as the other softwares because we only used a mesh size of 0.5, which is big and will not give accurate results. So we go to results. Now, as we can see, so we change here. This shows. We go to U to show the magnitude of the wall against the blast loading. So as you can see, the wall could not resist the blast loading, and the deflection was from the top part of the masonry wall, and the reinforced concrete was not that affected. The maximum deflection is in the red region, so this will show us how the explosion happened and how it affects the wall. Also, we can change to stress. Maximum principal shows the maximum principal stress, but mainly we're concerned about the displacement. Thank you guys for watching, and hope you subscribe and like my video. Thank you so much.